This is question 11 from exercise 3.4 in text and test 4 new edition. From a point A on the same level as the base of a radio mast, the angle of elevation of the top of the mast is 25 degrees. From a point B 20 meters closer to the mast and on the same level, the angle of elevation is 32 degrees. We have to find the height of the radio mast in meters correct to one decimal place. So there's a few things we're going to fill in our diagram before we start on this. I've already drawn a line from the top of the mast to the bottom just to close off our triangle. So we've got two right angle triangles, and it's going to fill in that it's a right angle down there. And I'm going to label some sizes so it's easier for me describing things. So I'm going to call the top of the mast point C, and the bottom of the mast down here point D. Now we're going to fill in the names of the angles that we know, or to measure the angles we know. So this angle over here, just to the left of the 32 degrees, is going to sum with 32 to make 180 because this is a straight line. So this angle in here is going to be 148 degrees, just in there. And if that's 148 and the other angle within the triangle is 25, it means the third one up here is going to be 7 degrees because all three of them have to sum up to 180. And then within our triangle to the right, we have a 90 degree angle, 32 degree angle, which means this angle on the top is going to have to be 58 degrees, like that. So we've got all of our angles together. What we need to do now if we want to try and find the height of the mast is we need to get the length of a line within our right angle triangle to start with. The easiest one to find is going to be obviously this hypotenuse here, which we will label x just to make this a bit easier on ourselves, and we're going to call the height over here h, just so that we're not writing out the lengthy names for this. So what we're going to do is we're going to say that the length of BC is equal to x, and then the length of CD is equal to h, just for our calculations. And we can use sine rule to get all of this done out. So we'll start off by getting our value for x. So it's going to be x over the sine of the angle opposite it, which is 25. So x over sine 25 degrees. And that's going to be equal to 20 over the sine of the angle opposite it, which is 7. Which means that our x is going to be equal to 20 sine 25 all over the sine of 7. So x is going to be approximately equal to, we're going to round this just to 3 decimal places. So 69.356, like that. And then we're going to use that to get our value for h. Now, when we have this, we could use just a standard trigonometric ratio. We can actually use the sine value for this. The sine of 32 is going to be equal to h over x. But since we're doing sine rule for our practice on this, we may as well keep going with sine rule for this one, which can still be used. So we're going to say that h over the sine of 32 is going to be equal to 69.356 over that sine of the angle opposite it, which is 90, so over the sine of 90. Which means that h is going to be equal to 69.356 times the sine of 32 all over the sine of 90. And that's going to give us 36.753, and if we round that to one decimal place as we're asked to in the question, that means that the height of the mast is going to be 36.8 meters. And that is that.